This is Aaron Murakami, and it's April 18th, 2015, out of Spokane, Washington here, and sitting right next to me is Eric Dollard, and he's in town, and we're working on his upcoming presentation, The Power of the Ether as Related to Music and Electricity. And another project that we have going on is, a lot of you are familiar with Eric's telluric research and his advanced seismic warning system, and there's been some campaigns on Indiegogo, and we have just recently launched another campaign which you can find on ericpdollard.com, and on the Indiegogo page we're looking at raising some funds to help pay off the building so that EPD Laboratories owns this outright, and also so we can get a little bit of equipment and bring the seismic project to the completion stage for the phase for 2015. And in the original campaign, there was a couple times there was a second antenna system that was alluded to, but we never really gave any details or showed pictures. There are a couple pictures on ericpdollard.com on the Long Lines Project photo albums or blog posts. But right here we're going to be going over a presentation, and Eric's going to kind of explain what you're going to be seeing in these pictures. First of all, a lot of you may have not even seen this logo, but I would actually like to cover that a little bit. Eric, can you tell us a little bit about what this logo is and what it means?
Well, this logo was extracted from a statue that was made for a Bell telephone, and it was the angel of electricity, and its hand was held up in the air with lightning bolts. And so I decided, being that we're kind of a continuation of all this Bell telephone engineering and realities, that I would capture that one part of it and make it into the logo. And of course the three-phase delta triangle is one of the archetypal symbols of polyphase power engineering, so it worked out pretty good. And then we used the Western Electric Bell telephone lettering just to finalize the situation. And then the A52 is a somewhat arbitrary number configuration for this whole project, the number of antennas, being that I was born in 1952 and this is Project A. But then there's the popular notions of Area 52, and that actually does have a connection with this, in that these two transmission structures and the land that's been granted to us by the government to build these things is on the east and west extremes of that part of Nevada that's known as the National Security Area.
Now now this has transmission structure, and through a lot of the advanced seismic warning system, bringing people's awareness up about it, it's been referred to as antennas, but technically they're not antennas, they're transmission structures.
That's correct. The Alexanderson line is not an antenna, it's a transmission structure for phasing the reception of electricity out of the ground. So the ground rods and or the plant roots that they're driven into are the actual antenna structure. The beverage part of it is basically tuned out so that it's not an antenna in the normal sense anymore, but it's a capacitor designed to intercept the dielectric lines of force that stand between the ionosphere and Earth. So basically the Alexanderson so-called antenna is really a waveguide, and the beverage antenna is really an electrostatic capacity. So there's no electromagnetism or standing waves or any of the normal antenna concepts involved. These are basically carrier telephone transmission lines that are being loaded and reconfigured into this unique transmission structure.
Okay. Well, we can go ahead and get into some of the pictures here. And we kind of have this separated into 5 different groups, and we'll start with group 0.
That make it 6.
Make it 6, yeah, including 0.
Right.
So this is group 0, cleaning up the mess. So what are we looking at here?
Well, what happens is when these lines get abandoned and people start to take note of it, then the hoons come in with their trucks and start smashing poles down and ripping wire apart and all that. So here they had come by and chainsawed one of the poles down, let the cross arms and wires and everything crash to the ground, because that's how these people entertain themselves.
So the government is actually supportive of you cleaning up some of this debris for safety hazard.
Well, yeah, that's part of our agreement. Is we got to clean up the mess, and we have to make all this safe. So there can't be dangling wires and dangerous stuff out there or unsightly. Here's another example where, they whacked the thing off and it crashed to the ground. So this is where we start to gather our hardware. Here I'm dragging about 3,000 or 4,000 feet of wire that was laying on the desert floor for the reeling process, and we recover that to build our structure out of. When the wire gets too heavy, then the car does the towing. So right now the car's done with the towing, and the remainder you can see on the roll what we've already taken up. I can pull with my own body.
Now, what kind of wire is this that you're reeling up here?
The reason why this wire is still there is because it has absolutely no scrap value. It's what's called copper weld. It's a strong steel wire with a copper coating to give it 40% of the conductivity of a wire that was solid copper. Because of the skin effect at these frequencies, the copper doesn't have to be any more than like a millimeter thick. So the rest of the wire can be steel for strength, and it makes it economical to buy large quantities of it. The phone company put in hundreds and hundreds, if not millions of miles of this stuff across the country at one time. This is the last residue of what's still standing. So because it has no value, it's just when these things get vandalized and damaged or improperly taken down, there's miles and miles of wire that needs to get cleaned up. So motorcycles don't get caught into it. There's a problem with wild horses getting tangled up in this stuff. So it's very important to the government that this stuff all get taken care of. So that's part of our arrangement to be able to use these places, is we clean up the mess.
Okay. And what's this?
That's an example of where the line was smashed off at the end, and the cross arms have been ripped apart by people taking their pickup trucks and tying them to the wires and that kind of stuff. So this is some of what we're cleaning up. And here I'm untangling. I cleaned up so far over 10 years about 40 miles of this stuff on this right of way. So this is about the last 1 or 2 miles now that I'm untangling, and we're rolling up. There's the recovery right there.
Now, is that wire going to be used for the seismic project?
Yeah, that's all going to go back up on poles.
So this is the main wire that you will be using for it?
Yeah, this is the wire we're going to use for the other antenna. The western one. The eastern one, the wire's already on the poles, but for the western one we have no wire or cross arms or anything. So we're using the cleanup debris to maintain the one that's already up and to build the one that's not up yet.
So the antenna, or this line of poles right here, is this like the second antenna system, or line system, or is this where you're just getting wire from?
This is just the smashed remains of where these lines went for. Typically an O carrier system was a 200-mile section with 60-mile spacing repeaters. So these are like the last places where this stuff is so far out in the desert that it was never properly taken down. And then, as you can see here, people have smashed the poles and yanked them over. It's so this is the wood cleanup. So we take all this stuff, and then this becomes the fuel for the campfire because it gets kind of cold out there. We did all this in November and December, and that's the glom residue. So this is the stuff that's going to put the other line, the western line up, is going to be put together with this. This is our glom.
So the all the poles near your shop, is that the east or the west one?
That's the west one.
Okay, and so then the east one, and the purpose of having two separate locations is so you can get a stereo effect.
Exactly.
So you can determine more of a location of
right.
where the activity is coming from.
Yeah, and they're spaced about 200 miles apart.
Okay.
So this is where the gun heads have shot up all the insulators. They like to do that. So they broke them all up, shot them off.
Target practice.
Yeah, target practice. Yeah. And then they smashed another pole over here with the chainsaw and the truck. And so we recover this stuff, and in the western antenna we have so many damaged or rotten poles that this cut up stuff is still long enough for the shorter poles where we don't need the height. And so we just salvage this stuff, and this is all going to go back up in the next year's phase of the project.
Okay. And now the next set of pictures is Group 1, repair and reconstruction of line portion to be utilized, pole pair.
Right, so we have a 1 mile section of line that can be stabilized and repaired and configured into this transmission structure. So this is where it was smashed off at the end. So now we're starting the cleanup process. First we have to detach the wires, and then we have to move all the debris and then assemble new arms. So this shows the step-by-step process. So the wires are being detached right now. That's the first step, is to get them all off and get all the tension taken up properly so the whole thing doesn't pull itself backwards. There's the wires actually being let loose now with the wire grip, and you see the rope on it, and then I grab the rope, or the car grabs the rope, and then we start letting the stuff loose backwards. It's dangerous work to do this stuff if you don't pay attention, so things can twist around on you. This is the other pole. That's going to be the dead end for the other pair, so we're starting the same process of detachment and cleanup. And that's a more distant view of that in progress. This is for the pole pair, so that's going to be the pole pair dead end. So the crap is coming off right now. And then, because this is the dead end, we have to dig holes for the anchors, and the metallic anchors are corroded out by this desert soil, and it's too hard to dig holes for them. So we're using the stub guy method, where the busted up poles that were smashed down by the hoons, we cut them into guy anchors, and then they're buried between 3 and 5 feet, sometimes 6, to take up the load on the dead end. So that's in progress now, and there's the pole it's going to connect to. So now the pole's been cleaned, and the guy's ready to go on. So these are the things that bite that we have to watch out, that are underfoot. That's a tarantula. And then now we're fabricating the dead end arms out of the glommed junk. And then they go up, and the wires are starting to get attached. And then we have the finished product, and that's the dead end.
Real clean looking.
Yep. And then the guy's attached, and the tension's taken up on the whole thing, and then that's it. One pole's finished. But there's 2 other pairs on this line, and they're dead ended on the next pole up, and that's what the next group of pictures shows.
So how long did it take to put the pole up, put the cross arms up?
The pole was already there.
Oh, the pole was
this is where the poles are still standing, and they haven't been vandalized or damaged. So each you're looking at a day's work between the 3 of us.
Okay. Now we're getting into Group 2, which is repair and reconstruction of the carrier pairs.
So that's the next pull up. So now we're starting the cleanup and assembly process. So here's the double arms that we fabricated are going up, and then they're assembled, balanced out, and then I have to start fabricating the guy. This one's going to have quite a load on it, so this we can't just, this one has to really be taken up with a big chain fault. So I'm getting ready for that now. The guy anchor was put in. Fooling with the wire, this stuff's kind of hard to handle. You got to watch out it doesn't poke your eye out.
There's a lot more work going on out here than most people realize.
Oh, yeah.
What you guys been doing out there in the desert.
Busy.
Yeah, non-stop.
Non-stop. Okay, so I get the thing centered into the preform. And then that's the finished product. I think the sequence is a little out here because the tensioning should be in there somewhere, but the next photograph will show that was taking up the load to get it ready to be finally wrapped. And then that is the finished product. So now I think that's the finished product. That's the end of the line as far as the carrier pairs, the 2 outside one, and then the pole pair in the middle was dead end by the next pull down that you saw in the other group of pictures. So this is where the terminal equipment connects.
Now in Group 3, removing 1 mile of extraneous pair conductors.
Right, so as you can see, there's 1 pair off to the side that we don't need for this because the situation has to be symmetrical, and it would just introduce a lot of intercapacitance and coupling problems between the pole pair and the carrier pairs. So we have to take this line down without yanking or having anything fly in space. So it's a very complicated process. So there's I think 12 poles in this one section, half-mile section, that we have to unwrap the wire from the insulators and then let the whole thing loose. And then, so this is where we're done. This is the finished transmission structure.
Okay.
That's what the one in the west is going to look like. It's like that we put up. This is the archetype that I've decided upon. It's not ideal, but there should be 2 cross arms, one for the overground, one for the underground, but I have to deal with what I have right now, so I have to kind of stress the situation a little bit in order to get immediate results. And then the next step here now, which we will not get to, because the main thing was to make this safe and clean up the mess. So we've completed our obligation to the government. That's the first step. Just like previously, we did that with the cable TV line on the west end, as that was our first order of business, was to, as you saw in the last set of photographs from that, was to remove the busted poles and the dangling wires and stabilize it. So now we stabilize this one, and then we will have to come back and put in the ground electrode next to the poles, and then the pole pair has to be, at every pole has to be sectionalized, so we have to cut the pair and then put the strain insulators in that section so that the loading network can be inserted in that section of the line that connect it to the ground terminal.
So besides a ground rod going by each pole, will there also be a box mounted to the pole with the
there'll be a
capacitors?
loading network will be up high next to the pairs, and then its 5th terminal is the earth connection, and that will go down the side of the pole, and then either we have to drill like a 30 or 40 foot hole to put a capacitance probe down in this terrain here. These particular type of bushes, you put the ground rod into the center of the bush, and their roots go down into the water table, and that usually obviates the need for drilling holes and busting rock, and because you're not going to pound a ground rod into this rock.
So it's easier on this antenna field.
Yeah, because we have the right vegetation. So this is closer to the Mojave Desert, where you have a lot of these greasewood bushes, and that's what I used in landers. Is they're very convenient for making your ground electrodes. So what you do is you find 3 of them and put a ground rod on all 3 and make like a star connection around the pole, and you can get well below that characteristic impedance of the transmission structure and start to extract out of the ground.
And so with the other line location, that's fused volcanic ash, so that's a little more challenging. Where we might
the plants can't get their roots in it, and there's no way to drive ground rods in it, and it's you really almost need. We have to get the mining people to use explosives to come in and make the initial holes for us and stuff. Because Justin and I, the 2 of us, in a full 8-hour workday, knocking ourselves silly working, only managed to get 6 inches in. So that's not practical. Right. So the line truck, if we can get the line truck, that'll help with that, because we have the lineman also that came with the line truck. That's kind of an unusual situation.
Right. He wants to do something.
He's very excited about this, about getting his truck back, and because there's no one to work for anymore, and even though he's old, he doesn't want to sit in front of the TV drinking beer. He wants to be out working on this. So, so he says that we can get, we can drill a lot of our guy anchor and pull holes with the truck. Okay. So this area here is too remote to bring the truck.
Right. So
it's almost impossible for even get the car into some of these places, as you'll see in the later photographs.
Okay. Now in Group 4, Raiders of the Lost Glom.
Yeah, this was it wasn't quite calculated on that that there's going to be money spent in this direction, but then the Glommeister had determined, in the process of him cleaning up some old surplus facility, that he'd come across all of this line hardware and network capacitors and coils and other things that were really needed. So we put we spent about $3,800 recovering this stuff. We had to haul it about 600-800 miles, and opened these old crates from the 50s, and all this stuff that that we're using is just all there, brand new, all wrapped up. It was a U.S. Army Signal Corps project.
So for $3,800, I mean, this would cost an absolute fortune if you'd have to.
Oh well, the patch bays would have cost hundreds of thousands of dollars.
Yeah.
We got a whole bunch of the inside plant stuff too. So these are like cases of insulators. And that's the insulators themselves. You get an idea. This is an extremely valuable situation.
Yeah.
So this will be, when larger lines get built later on, where we have to repair stuff. The other thing I'm finding too is some of the operating phone companies are still forced to keep these lines in operation, and they have no supply of materials or engineering knowledge. So we are in a position now to assist the operating companies in keeping what few of these lines they have to keep going, up and running. So it's going to be an interesting relationship developing between us. This is new climbing hardware. So Justin and myself, he's doing most of the climbing now. He's had to use my lineman's belt and climbers from landers that were given to me after 40 years from a telephone lineman. So they're getting kind of worn out. So lo and behold, in the Glom warehouse is all brand new stuff. Made I think these things were made shortly after I was born, and they've been sitting there all this time waiting for us.
New old stock.
So that's the little military packages that the stuff comes in. And this is offloading it into the garage at the building. That's all the pins for the insulators, all brand new. And then we're putting the stuff out in the pull yard. You can see the glom from previous episodes, all the ceramic insulators and all that stuff piled up to the right. That was from the 2.2 mile line we took down for the water department. So they wanted it completely gone, and we couldn't use it as an antenna. And of course, whatever we got out of it, was ours for the work. We did it all for free. So that's kind of what EPD Laboratories does. Is we kind of, as we say, we do the necessary. The utility company or somebody has a complication with this stuff, then we assist them for free, and then in turn they help us.
Let's see. So on Group 5, the Corolla movement and habitation of the desert environment.
Yeah, this is my actual life and moving around. So plunging the brush, that's one interesting phenomenon, and you got to watch out for sinkholes. We lost the Toyota pickup truck into a mystery sinkhole, and it was quite an operation to get it back out. We did it. Thank God, it's a Toyota truck. It was strong. We got the thing back out. This is like one of the Corolla trails to get back up into part of the desert. So these are the places that I live. So this is my home. So I just don't go there and leave. I live in these places. So these are the areas that I navigate. As you can see, they're quite beautiful places. So this is a dry riverbed that I worked my way up. The whole railroad bridge. And then that's where I set up camp. So the sun's going down now, and we're setting up, getting ready to make dinner. So there's the dinner assembly. This is how I live outside. This is a daily process. Dinner assembly. And then the junk wood makes the campfire, and then we go dig up old railroad junk, and we make ourselves a stove out of it, and can make some damn good dinners here. So, and then we're getting loaded up for the trip out. And then that's the end of the day. And then it's time to go to sleep.
Beautiful sunset.
Great place to live.
Right. So that's the Area 52E line project.
So that's kind of a quick synopsis of what we do out there, and then there'll be more pictures on the website.
Yeah, on ericpdollard.com, we'll be putting this photo set here, in addition to a bunch of other photos that were not included in this particular presentation, but it's all from the same sequence of photos. And on ericpdollard.com, there's a link right on the home page to the Indiegogo campaign, where you can go there, you can learn a little bit more about the Advanced Seismic Warning System, and please donate what you can and help make this project a reality. As you can see, they've been busy out in the desert have been acquiring not only a lot of the supplies that they need to put the lines up, but they're actually putting the lines up, putting the cross arms up, getting the wires up, securing these poles, and this is all going to be quite a phenomenal project. And by the end of the year, you can help us bring this to at least the phase where we'll be able to receive signals out of the ground.
Right.
And so definitely go to ericpdollar.com and please share this because I'd like to restate that a lot of people think this is just about earthquakes, and a lot of people have been asking, well, why earthquakes? But in reality, once these lines are up and everything gets more to a completion, there's actually a lot of different experiments that could be run on these lines. Is that right?
Well, it really helps gain an understanding of what the electrical world is like inside the Earth. It's a very sophisticated system of waves, and it's an unknown world. Mm-hmm. And these are like radio telescopes to look inside the Earth.
Right.
That's basically how they're being utilized.
Right. Which nobody is talking about.
Right, but one that's going to be a true radio telescope would have to be like 15 or 20 miles long, and we're not even near that point yet. We have to have major funding for that. Mm-hmm. But at any rate, the government will supply the land and give us the right-of-ways, and fortunately, we have received a seismograph installation from the state, and now that's in our government right away. So we have an extremely exotic seismic pickup system that would be hell to find, and because it's analog, they rejected it, and then through the local municipality, because we're going to provide the seismographs and the advanced seismic warning system there for that town, then the federal government just transferred the thing over without any further expense or to do. It's now part of our right-of-way. So that was a big step forward.
And so the seismograph in the mine, which is right next to the lines over in the
in the western section,
western section near the shop, that so the seismograph is connected to mechanical stress indicators or whatever you want to call them.
Yeah, these are what are called variable reluctance pickups. What they are is they're giant phonograph cartridges that weigh 400 pounds. And they use the inertia of their the moving part of it, so that the inertia tends to keep the armature, so to speak, stable. And so if the ground moves, then there's a relative movement, and these massive coils pick it up. And we have 3 of these for each of the 3 coordinates of up and down, right and left, and fore and aft. So that's good, and then they're deep in a mine, so we don't have any problem with wind or any external disturbances like coyotes running around or rats jumping on top of your stuff. So, and it's 4 pole spans away from our transmission structure. So, the idea with that is to run all these leads into town, but unfortunately we have to put up 25 poles and find the wire and all that for the transmission section that delivers it to the town. That's going to cost some big money. So the only thing we can do right now is to try to put the terminal facility right there at the mine. Mm-hmm. But then again, to build any type of carrier repeater type building or carrier terminal building is $125,000. So we're kind of stuck right now with whatever we can do by putting repeater cabinets on poles. Right. This is a very expensive project.
So with the seismographs, so that picks up the physical movement of the ground,
right?
And that's one of 4 pieces of data. The lines show the above and below ground signals.
The electrical aspect, and then there's the mechanical aspect, and then, as I've pointed out before, in my situation, normally the seismic pickup, at least in the old days, was connected by a metallic pair straight to a moving coil on a chart recorder, and an earthquake of like 2 or 3 magnitude would make a 1/4 inch or 1/2 inch mark on the recorder, or maybe an inch. In my system, I run it through power amplification of 1 billion, so that rat's running on the ground, if you turn it up all the way, will make a 1/4 inch movement. Wow. And that way all the generalized seismic movement of the entire Earth is captured that way, not just the locale. And then you have to make sure to use peak limiters, because if there ever was a 2 or 3 magnitude earthquake, the signal would be so strong it would rip the chart recorder apart. So you have to have a deliberate saturation level in your vacuum tubes, or have some kind of semiconductor shunts. So this is what I had at Landers, and it's fascinating to have a seismograph that's so sensitive that you can watch on an oscilloscope waves like water, which are the surface of the Earth.
Mm-hmm. And then the other part of the data needed to put all this together to see a picture of the Earth activity is the solar flux.
Well, the solar flux is another dimension, so that goes along with this, but that's not a direct connection to what we're doing.
Mm-hmm.
That's for the ionospheric end of it, which there's no money, place, parts availability, or anything to advance on that project. But that involves the solar activity in the ionosphere.
Mm-hmm.
So I had several systems at Landers. This Landers was not isolated to just one specific project. There were several of them there involving the solar flux and the ionosphere, an HF propagation, and all kinds of different things with its associated equipment. So this is strictly the Earth signal portion of it.
Okay.
But the rhombics and log periodics and HF receiving equipment and all that stuff that I don't have, then that studies the ionosphere.
Okay.
And ultimately there's connections between all of them. So the more diverse dimensions you have in your receiving and analyzing capability, the more you're going to find that there's interconnections between all this stuff. So that's the science end of the project.
Right.
What you're looking at right now in these photographs is the engineering end. We already know what we want to build. We know what we're going to do, and we know what to expect. But the scientific study, we're trying to at least get to the point where we can get back to doing some more full-blown research of how all this stuff connects together and building bigger structures to study the inside of the Earth.
Okay. So please go to ericpdollard.com and look for the Indiegogo link, and please support it however you can, whether it's a large donation or small donation, and we're going to look at putting some more perks up there. A lot of pretty cool things. Some of them even include coming and spending a few days with Eric and getting tutored on what you want, or checking out the seismic project, and there's a few other things that you can see on the Indiegogo site. And please share this with your friends. A lot of people are becoming more and more interested in a lot of this Tesla type technology and related sciences and stuff. But this is one of the few projects that really is directly related to a lot of the stuff Tesla and Alexanderson was working on that almost nobody knows anything about. And this is not just theoretical. Go on to ericpdollard.com and look for the Landers photos, and you can see how this was all put together and working before. And actually on extraluminaltransmission.com, this is the presentation Eric gave at the 2014 conference in Hayden, Idaho last year, and that's directly related to a lot of this. And on that website there's a couple videos of Landers, and if you're interested in seeing what the end result may look like, there's two videos on the Telluric research. One is a couple-hour video that's more of kind of a casual tour, but there's also a 4-hour technical walkthrough on this facility where you can see it in action. And Eric is walking around the transmission line setup and going over some of the equipment inside the building, showing some of the signals on the scopes. He's even going over a couple equations, some of the math early on in that video. And so you can see that this is a very real technology that works, and we're going to do what we can to rebuild this system and having it receive signals by the end of the year. So again, ericpdollard.com, and look for the Indiegogo link, and please donate what you can and share this with your friends. Any final words, Eric?
No, I think that pretty much covers it.
Okay, and we'll be releasing some more info, and if you want to see Eric at the upcoming conference this July, his presentation is The Power of the Ether as Related to Music and Electricity. You can go to EnergyScienceConference.com. Out of 150 seats, there's only about 55 that are left, and so you want to definitely get that locked in because they're going pretty quick. And there's a couple other interviews and some videos that interviews that Adam Bull and myself have done that we're still going to be putting on YouTube, and so stay tuned for those.